Hey everybody, this is Larry. Hit the like button and the subscribe button on Discord. I don't know what day it is. I just ran 10 miles. Let's go. Let's do today's problem now. Let's go. Hey everybody, this is Larry. Yeah, as you saw in the intro, doing 2 more weeks to the marathon. So I've been counting down the days. The last long one of the year, or not the year, the training session anyway. We'll see what happens afterwards. But yeah, only 10 miles, but I didn't sleep that well yesterday, or at all really. I took a little bit nap in the afternoon, but yeah, not so good, not so Gucci. But you know, I'm here now, and I'm still so tired I want to pass out. But before that, let's take a look at today's problem. Hit the like button, hit the subscribe button, join me on Discord. Thanks for watching, and let's keep going. Today we have 2530 Maximal score after applying K operations. I just had a lot of watercress. I hope that my teeth isn't green or something. It might be a little bit. Now I'm a little self-conscious. Anyway. Alright, you're given a 0 index integer array nums and an integer k, you have a starting score of 0. In one operation, choose an index I such that 0 is less than or equal to I and less than n. Increase your score by num sub I, and then replace it with zeroing of n sub I, or what x sub I or whatever. Return the maximum possible resources you can obtain applying side k operations. Okay. So basically, we want to right? So the key thing to know about this problem is that this is greedy, right? There's probably a good I think for this one, honestly, the intuition is probably not that difficult, but the reason is because every number, the focus is on number 3 on the operation, right? The part 3 of the operation, which is that we replace a number in a very deterministic way, and also with this number, right? Basically we're replacing a number x with x over 3 round up. But that's going to always be that function is there's no choice in the function, right? Meaning that the bigger number that you take, x, you replace it with a bigger number anyway. So, you know, you could probably do some argument about, you know, the exchange argument or something like that. But this kind of like, you know, because when people think about, when you want to think about greedy and talking about these kind of algorithms, the thing is about choices, right, and making decisions. And the thing about greedy is that the logo how is it phrasing, the best local move gives you the best local score, for the best global score, right? So that's really the idea. And here we wanted to do greedy. Okay, what do we do after we do greedy, right? Keeping in mind that you cannot just like sort, because for example, maybe in this case you have like 100 divided by 2 is 33. You keep going again, and then 33 you get 11. Then, you know, so you could do a number multiple times. And of course, now that you think about it, you know, those terms, you go, okay, then we just want to keep on getting the biggest number. And what allows you to get the biggest number? K times, I suppose, right? And the answer is, of course, heap. So let's do it. Yeah. So then we have a heap, and then for x and nums, I know you could use heapify, but I just want to do this way. And here we want to get the biggest number, so we're just going to do a little bit of a hack with negative x. I really should figure out if there's a cleaner way to do it, because I think at some point it's a little bit tricky, you know. And then now we do a k loop, right? We go, okay, so then we pop off the biggest number, right? So x is equal to this number, or negative of this number, because we have, you know, this is a negative, right? So then now total we added by x, and then now we want to do the CO. Of course, you can check this, but this will give you this the number of 3 round up in integer. The reason why you want to do an integer is so that you don't have to deal with floats and stuff like this. Floats are icky. I mean, now they're fine, but I feel like most people do not really think about the error bars and stuff like this when you deal with floats. But this, is pretty good, right? So then here we have maybe small n for the next number, and you can actually just push it back in the heap. But the way that I like it is that I just want to make sure that it's greater than 0, because then actually no, let's just always push in the heap, because I think if you do the thing where you what I was going to say, then you may actually run out of numbers if you're not careful, and then you just get a silly wrong answer. But instead you could just do, again, push it back, and even if it's an X, it's fine, who cares, you just only do K loops anyway. And now that should be good. Unless it's not, then I'm a sad boy. A sad boy. And that's pretty much it. Yeah, I mean, the code is easy to look at and to read, but of course you have to I think the people people struggle with greedy problems on my this is one of the biggest questions that I get, especially for people who are in the beginner and the intermediate level, and it is something that I would say is something that I struggle with a lot during a contest, is greedy problems and proving them. So and the thing is that greedy problems often rely on but there's an intuition to greedy problems that gets you in trouble, because you're like, oh, it's obvious. Well, it's only obvious because you got it right, but it doesn't mean that you prove it. It doesn't mean you understood the proof. It doesn't mean that it's repeatable for problems that are similar enough but not quite, because greedy can mean a lot of different things. So definitely think about these things when you work on these sorts of problems. But I am tired, so that's all I have for today. Thanks for watching. Stay good, stay healthy, to good mental health. I will see y'all later. Take care. Bye bye.